Hi, and welcome back to Waveform Science. I'm Jeff Hagan. Tonight we're going to charge everything from Bluetti's B80 battery in Powerbank mode. So first off, what is Powerbank mode and why do we care? Powerbank mode takes the B80 battery and it configures it to output the native unregulated battery cell voltage that's actually running inside the device, take that voltage and route it to this aviation port connector that's on the side of the battery. So this isn't a connector that I'm going to be able to find anywhere. So in order to use this feature, we need to use this cable that wasn't available from Bluetti until this is actually a review unit. It's still not available from Bluetti at this time. But without this cable, it's not practical to use the mode. That's why I didn't cover this mode in my B80 video, because I didn't have the cable yet. So what does this cable do? So on one side of it, you've got the aviation connector. So I've got the two larger pins. That is what is actually carrying your power. And then I've got a bunch of smaller pins. Those are data pins. That allows the B80 to communicate with the cable. So this is actually a data-enabled cable in theory, which is why you can't just easily build one. You kind of got to get these from Bluetti. So the other side of this cable has a DC7909 power connector, which Bluetti uses on pretty much everything they make. So that's the actual cable. How do I get it into Powerbank mode? So pretty simple. Take the cable. It's got a lock tab on the top, just like the other ones do. Plug the cable into the side of the battery. Just push. Now we've got it plugged in. Now what we do is we push and hold the power button until it just turns green. As soon as it turns green, you let up, and it should start flashing. If it doesn't start blinking, then you probably need a firmware upgrade on your B80 battery. I'm not 100% sure as to which firmware the B80 batteries were originally shipping with, but there is a version of the firmware that this actually doesn't work on, and you have to update it. So push and hold till it starts blinking, then you'll have power coming out of this end of the cable. How much voltage and amperage do I expect to see out of the B80 battery when in Powerbank mode? So amperage is easy. This DC7909 barrel jack connector, these are rated for 10 amps. So if you try to pull a lot more than 10 amps out of these, you're going to wind up with all kinds of problems. The connector will get too hot, it will melt, bad things. So this is a 10 amp connector. So given that this connector is in play, the most we can expect to get out of here is 10 amps. Voltage. That's a different story. So I've got a voltmeter here, and I'm going to plug the Powerbank mode into voltmeter. So how do I do that? Back here I have a DC7909 input cable that I can plug the DC7909 output cable to, and that's running around to the voltmeter. Let's give the voltmeter a second to figure out what units to use. I'm getting about a little over 23 volts out of here. And that's, of course, with no load attached. We're going to have much lower voltage coming out of it when you do attach a load, because like everything, when you attach a load to a DC circuit, you're going to get some amount of voltage drop. So the float voltage here, about 23.1 volts. That's what it is when I've got no load on it. Then when I start applying a load, let's get it up to about 8 amps, because that's what all of our Bluetti devices are going to charge at. There we go, that's right about 8 amps. You can see that my voltage here drops to 22.3, a little bit close to 22.5 volts as my working voltage to start with. And that's going to maintain relatively flat until about 4.5 hours later, when the battery goes dead and it drops to 0. Lithium iron phosphate batteries have relatively flat discharge curves, which means that we're not going to see below around 21-ish volts, where it hits 21-ish volts right as the battery really starts to die. We get another 10 minutes or so, 15 minutes or so out of it after it gets to 21 volts. But realistically, we're looking at about a 22.5 volt to 21 volt device during the discharge curve. Before we start plugging things in, let's see what it would mean to have a successful test. So we know the output voltage of the B80. And we know the input voltage of pretty much every solar controller Bluetti makes these days. So let's take a look at it. So here's a graph with all of what I call the smaller Bluettis, EB3A, EB55, EB70S, AC60. They're very, very similar in the solar controller response curves. So the area that I would expect to see being exercised by the B80 battery is now highlighted in red. So we're going to expect somewhere between about 165 watts to about 185-ish watts at maximum in the voltage range that the B80 battery operates in, and that's on the smaller, the EB3A, EB55, EB70S, AC60, on those. Moving up one size larger, DC charging enhancer and AC180. Both of those operate in about a 12 volt to 60 volt range. So how much charging speed would I expect there? Somewhere between about 160 and a little bit over 200 watts, somewhere in that range. What would I expect for the AC200 Max? AC200 Max charging curve, again, I'm highlighting the areas that are interesting. We're going to get somewhere between about 140 to 220 watts, kind of depends on the voltage. Now 220 is a 27 volt range, it doesn't go up that high, so that's higher than the maximum. So really it's more like 140 to about 200-ish watts. And that's assuming we're going into the solar controller and not the DC charging enhancer. So what this comes down to is on all the different Bluetti devices, we're expecting effectively between about 140 watts and at maximum about 200 watts of charging out of a B80 battery when plugged into a Bluetti device. Can I recharge an EB3A? Plug it in, it immediately turns on its own, and it starts charging. We're getting about 183 watts roughly. I normally make very detailed discharge efficiency graphs for the various solar generators that I've tested because, as you guys know, discharge efficiency is not constant across different loads. However, in the case of the B80 battery's power bank mode, it didn't make sense to make those kinds of graphs. So the reason it doesn't make sense to make those types of graphs is every Bluetti device you're going to plug this into is going to recharge at 8 amps. They're all going to go the same speed. So the only speed that we care about is 8 amps. And that's the graph you're looking at. This is the voltage over time. So how much power were we able to get out of here? Well, 763.83 watt hours is what I measured, 94% efficiency. That sounds real good. But that's not the whole story. Let's say I'm plugging this into an EB3A. The EB3A charges from DC with about a 90% efficiency, meaning that it uses 296.7 roughly watt hours to recharge a 268 watt hour battery. So 90% efficiency of 94% efficiency, my recharging efficiency is 84.6%. So I lose about 15% of the power just by running from one battery to another. But now running it into the battery of the EB3A is not my end goal. Well, it's interesting to be able to do that. That's not the overall goal. I want to actually be able to use that power. So let's assume for a moment that I'm using it at 100 watts rate, and let's assume for a moment I'm using it from AC power. The discharge efficiency of an EB3A at 100 watts AC is 80.8%, almost 81%. 80.8% of 84.6% is 68.3%. So that means that if I start with power in my B80 battery, 68% of that, so I lose about 30% of the power, 68.3% of the power is available for use out of the AC socket of the EB3A when you're done charging it from the B80 battery. So it's nowhere near as efficient as using a device that has a native control for external batteries, like say the AC60 here does. You can see in this graph that the percentage loss of having the B80s attached versus not having the B80s attached is not all that different. But with chaining, when we're running one battery into another battery, we lose a bunch of power. And again, it doesn't make sense to show graphs for every single device, so I'm cherry picking one single example here because there's so many different devices we've talked about and so much different data. So just understand that there is going to be a big efficiency hit when you charge one battery from another battery. But is a 30% loss horrible? Not really. I mean, it's still definitely usable. And if you've got solar running into your B80, as long as you've got enough solar panels running into it to handle your load, does it really matter? Food for thought. Can I recharge an EB70S from a B80 battery? It turns on its own and starts charging. We're getting just about 170-ish, 180-ish watts. Can I recharge an EB55? Well, yes, but I'm going to need an adapter. This input port here, that one is for a battery charger profile. In other words, it's not going to work straight from the B80. You need a battery charger to plug into this where the external circuitry is in the battery charger itself, not in the EB55. Meaning I'm going to have to plug my straight voltage into the DC MPPT port, which this plug doesn't fit. So what I'm going to need to make that work is this adapter plug. So on one side I've got the DC 7909 pin. On the other side I've got an XT60. Bluetti sells these. They come with the T200S adapter, which, by the way, if you've seen my B80 video, that's how I recommend recharging this B80 if you're not using it with an AC60. When you buy one of those, it comes with this adapter, which you're going to need to recharge an EB55. As far as I can tell, Bluetti doesn't sell this adapter separately. Not entirely sure why, but they're pretty easy to find on Amazon by other companies. Here's an example. So how you would use this adapter is you would take it and you'd plug it into the output port. There we go. Now I've got my XT60. And now I just plug that in up here. And again, it turns on its own. And it starts charging. And I'm going to get about the same charging rate that I got with the other two devices so far. Right around 170 watts. AC60. Now, why would I want to recharge this with Powerbank mode? Why? Why does this even make sense? Aha, that makes more sense. Let's say I have an AC60 that already has two B80s attached and I need even more capacity. Well, what can I do? I can take another B80 battery that's in Powerbank mode and I can just plug that into the solar input on the AC60. Now, if I had panels plugged into this AC60, I could simply plug those panels into the B80 here. So I don't actually lose any solar capacity when I do that, because this solar input and this solar input can both handle the same panels. So whatever's plugged in here can plug in there. And I'm going to start charging. And I charge right around 190 watts. And of course I can do exactly the same thing into one of the inputs on the B80 battery itself. Don't have to actually plug it in up here. I can plug it in down here and it'll charge exactly the same. We're looking at about 180, 185-ish watts, somewhere around there. Can we recharge an AC180? Plug it in. The device turns on its own and it begins to charge. We get about 180-ish watts. Starting with the AC180, and as we go larger, I would like to remind folks that charging a bigger battery from a smaller battery will leave, potentially, the smaller battery completely drained. It is not a good idea for these particular battery chemistries to leave them in a completely drained state, for any length of time anyway. So I only recommend daisy chaining devices that are larger than the B80 battery from the B80 battery when there is some kind of ability to easily recharge. Solar panels, charging off a car, charging off the AC input through the T200S adapter. Just consider you don't want to leave these batteries completely dead. AC200 Max. There are two ways to do this on the AC200 Max. First off, On the side of the device, there are two ports. First off, there is a DC input charging port. That expects a battery charger on the other side. And there's a solar input port. That expects just straight DC, which is what we get out of the B80. So let's play with that one first. So the cord that comes from the factory for the solar port has the aviation connector on one side, and the other side has this. It's an XT90, which a DC7909 needs an adapter, but luckily on Bluetti's website they sell this adapter, which has XT90 on one side and DC7909 female on the other. So that plugs in right here. And then my battery would plug in there, but first I have to change the settings in the menu. So in the menu of the device, we need to go in and change it to be other mode. Not PV mode, but other mode. Once we've made that change, now we can go back out. By the way, you can't make that change once the thing's plugged in, so you have to make the change ahead of time. Once that change is made, now I can plug the battery in. Give it a moment for the solar to find it. And we're going to start charging at around 180-ish watts. There is a second way to charge with the AC200 Max, or if you've got an AC200 Original or an AC200P, this is the only way to do it. You're going to need the DC charging enhancer, the return of the DC charging enhancer. So what does this do? It takes in as an input, it is a solar controller in a box. So it takes in as its input anywhere between 12 and 60 volts. And it outputs a battery charging profile that plugs into the charging port on your AC200, AC200P, AC200 Max, B230 battery, B300 battery, B300S battery, and possibly more that I've forgotten. Oh yes, you can plug it into the AC180 as well, but there really isn't any point to do that. So how does this work? So same thing as the previous one, this has an XT90 input, which means you're going to need the adapter cable to get that to have a DC7909 input on it. Now we're going to go ahead and plug this in. That's plugged into my Bluetti AC200 Max now. And now we just plug this cable into the DC charging enhancer. I'll get the little light turning on. And that will take a second because it's going to have to spin up inside the DC charging enhancer, and then the AC200 Max is going to find it. There we go, it found it. We are going to charge a tiny, tiny bit faster from the DC charging enhancer versus without the DC charging enhancer on the AC200 Max. Is it worth the money for the DC charging enhancer just to charge a little bit faster off the B80 battery? No, not really. But it is an option if you've already got panels hooked up to your AC200 Max, because the voltage input of the panels is much higher than what the B80 can handle. So I can't simply always just unplug my panels from my AC200 Max and plug them into the B80, because I might burn out the input on the B80. However, the DC charging enhancer does in fact let me charge from the B80 to the AC200 Max. Now, again, this is a bigger battery, so this is going to completely go dead before it finishes filling this, even though this is at half full. This has got, a kilowatt hour battery storage left in here, and this only holds 806 watt hours. So this battery will be completely empty before this fills. And it's going to take like 4 hours to fill it or something. Yeah, somewhere around that. So it'll completely discharge before the battery is done. But this method here with the DC charging enhancers, this is the only way to do it with the AC200P or the AC200 Original. B230 battery. Can you recharge the B230 battery from the B80? Well, yes. I mean, it's somewhat pointless to do so, but you can. I mean, in case you had some need to do it. Same as before, this is a charging input, not a solar input, so you cannot plug the output of the B80 directly into this input. In fact, this battery doesn't have a solar charging input, so we're going to have to again go back to our old friend, the DC charging enhancer, with the same adapter that we just saw for the B230, or excuse me, for the AC200 Max. Plug that in, and plug this in, and there we go. Now we've got it all plugged in. And what's happening on the B230? Nothing. Nothing happens at all. Even though the charging adapter is turned on, nothing happens. Why? Because the B230 won't charge till you push the button to turn it on. There. Now once it turns on, it should, in theory, start charging in just a moment. There we go. My charging light has turned red and I'm getting charging. Well, now we've entered the land of the absurd. So can you recharge an AC500 with a B300S battery from a B80 battery in power bank mode? And the answer is yes. Now you need the same adapter, exactly the same adapter that we use with the AC200 Max, and that simply plugs into the side of the battery. That's all there is to it. You can leave all your other solar and everything else hooked up unless you've got solar already running into this. Then you'll have to unplug that, but the battery powers itself on and starts charging. Now the screen of the battery itself, the screen of the AC500 itself is not going to show the charge because it's coming in through the battery. But you will see the lights on the battery itself will blink to show that the battery itself is charging. And it will charge at a 200 watt rate roughly. I don't have the meter hooked up right now, but that's what you're going to see. So the ones that I didn't cover, and I'm not actually going to show you because it's a little bit too absurd, would be the EP500 and or the EP500 Pro. The EP500 itself, there's nothing you can do. It's not going to work. Unfortunately, the solar input voltage range is too high. It starts at 55 volts. And even with the DC charging enhancer, you're not going to get the voltage up that high. So yeah, that one you're kind of sunk. The EP500 Pro, you have to make a funky cable. You can do it, but you need the cable. It comes with a cable that kind of looks like this one. Basically the same cable they use on the AC500, AC300. So it's got this on one end and some solar prongs on the other. What you have to do is make a cable that looks like this, that basically has reversed polarity MC4, a la the same polarity that would come from a solar panel, which is the opposite polarity of this device. So you'd have to make one of those and have the other end of it connect to a DC7909 female. I don't know anybody who makes this cable. You can't buy this as far as I can tell. You can cobble it together from some other pieces. So I used the XT60 to DC7909 that I showed earlier. I used a XT60 to Anderson, and this one I just made. It's got an Anderson on one side and the MC4s on the other, because I couldn't find anybody that made this in the correct polarity. So yeah, it can be done on the EP500 Pro, but there's not a lot of point to do it because you're charging a really huge battery with a battery less than, 1/5 the size. So it can work, but why? As far as compatibility, that EP500 original is actually the only thing in Bluetti's current lineup that can't be charged by the B80 battery. Everything else can be. Some of them need a DC charging enhancer for it to work, but this is basically the universal charger. So that's pretty cool. The other thing you can do with it that I haven't called out yet is you can charge non-Bluetti stuff. A lot of your 24 volt appliances, 24 volt refrigerators, maybe some of the air conditioners. I haven't looked into enough to tell what the amperage requirements on those are, but it's possible where some 24 volt camping appliances, if they can take a low enough voltage, they'll work just fine because it isn't quite 24 volts, but it's close. So here's an example. This is from the instruction manual for an Iceco fridge, and I did nothing with Iceco. I just picked them randomly. They happen to have a refrigerator, and it happens to have voltages in the manual. So here's the manual, and if you set the cutoff to low, it'll actually run just fine off of the B80 battery with no difficulty at all. And if you wanted to run a 24 volt appliance that needs full 24 volts, not 22.5, but full 24, there's a trick for that too. I have the B80 battery here in power bank mode again. It's hooked up to my voltage meter, same one we saw earlier. Looking at 23.2 volts, same as we saw before. Except now I want to run a 24 volt appliance. What do? Well, my good buddy, the DC to DC voltage converter. This particular one has 18 to 36 volts in, 24 volts out at 20 amps. So 22 volts, 23 volts is in the middle of this 18 to 36 volt range, and it should give me 24 volts out. So all I need to do is plug this into the right order here, make sure I don't do this backwards. And get that aside there, and get this side here. And I should have, when the meter wakes up, look at that, 22.4 volts. So this will keep, assuming you have enough amperage, this will keep your 24 volt appliances running just fine. Now, this particular device is rated at twice the power that I need. So this one is rated for 20 amps. Well, I can only get 10 amps through this connector that's coming off the back of the B80. So that's my limitation, is right here, this connector. So that'll let me run 24 volt appliances as long as they run off of, less than 10 amps of power. I can do exactly the same trick if I want 13.8 volts to come out of there instead of 24 volts. So it's 18 to 35 in, 13.8 volts out. Very nice. Which side's the input? So I'm going to plug this from the B80 battery into the input. There we go. I'm going to plug the meter into my output. There we go. And now my meter should be reading about 13.8 volts, assuming this device works. Oh, look, 13.8 volts. Very nice. Now, this device is rated for 30 amps because, not because I'm actually going to be able to get 30 amps out, it's because I don't want this to overheat if I run it at load. Now, this will do 10 amps at 24 volts. That is equivalent to 20 amps at 13.8 volts, which means now I can have an output on my B80 battery that's better than a cigarette lighter at 13.8 volts. So if you're going to run a van and you want to run it off a B80 battery, you can pick up one of these and you can get a bigger output on your B80 battery. Now, of course, the downside is it uses the same connector that would normally go to the AC60 head unit. So if you're going to do this, then your B80 battery cannot be plugged into an AC60 head unit. You're running with standalone battery at this point. But it does mean that the B80 battery is actually a feasible device in order to run a camper, DC only camper, with just the output. And by the way, just because it's in Powerbank mode, you can still turn on the DC outputs. So you still have the USB, the USB-A, and by the way, another 12 volt cigarette lighter. And those all work at the same time as the Powerbank mode. Now you are limited in charging. This is only going to take, as we said in the B80 video, 200 watts. So if your average power load is over 200 watts, this device is not going to work for you. But if you want a device that can run potentially bursty 13.8 volt or 24 volt appliances, they're not using tons of power all the time, but they're using a bunch of power some of the time. This will absolutely do the job, and you can plug in your laptop or your phone or whatever else on here and some kind of a 12 volt appliance. So the battery itself, this is a great battery. This is going to be super useful for all kinds of fun things. The power coming out of here is almost enough power, not quite enough, but almost enough to run a ham radio at full power. So I can definitely run it at medium power off of this. And this is one of the smallest things Bluetti makes that I can do that for. So, B80 battery, let me know what you think in the comments. As always, I am not paid to make these videos. Bluetti does not pay me any money. I do this because I enjoy it. The products themselves, some of them were sent as review units for other videos. Some of them I bought myself. So it's kind of a mix. But Bluetti does not get to see this video before it goes public. They don't get to critique my thoughts. They certainly don't get to tell me what to say. So there's that. I make these because they're fun. You'll notice I don't have monetization turned on the channel, and I don't have any plans to do so. I just do this because I enjoy it, and as long as you guys keep enjoying watching the videos, I keep enjoying making the videos, then we'll have some fun with this. So thank you all for watching, and come on back next time.